All right, so for the rest of this page, all you're going to do is use your synthetic substitution. So this nice, lovely synthetic substitution to evaluate the function at c. Now, notice they gave you c. It's not a factor. It's not an x minus 3, x plus 3. It is just negative 3. So that is the value that goes in your half box. You do not need to change the sign when you're using the remainder theorem to evaluate. So that negative 3 goes in the half box, and then you're just going to write down your coefficients. Notice I have 1x to the fourth, 8x to the third. Here we go. 8x to the third, 12x squared, negative 7x, and then a negative 14. All right. Again, you're just looking for your remainder. You don't even need to worry about x's this whole remainder theorem lesson. Okay, so 1 drops straight down times negative 3. 8 minus 3 is 5 times negative 3 is negative 15. 12 minus 15 is negative 3 times negative 3 is 9. Minus 7 is 2 times negative 3 is negative 6. Negative 14 plus negative 6 is negative 20. And that's all you do. You circle that. That's your answer. And you go on to the next one. All right, let's try this one in my half box. Again, do not change the sign. Oh, we love it when it's a 1. This one's nice and easy. Now we just write down all of our coefficients. We've got a 3, a 2, a 4, a 3, a 2, and a negative 3. Whoops, where did my 3 go? Right there, negative 3. All right, again, we're just looking for that remainder. Okay, 3 drops straight down, times 1 is 3, plus 2 is 5, times 1 is 5, plus 4, 9 times 1, 3 plus 9, 12 times 1, 14 times 1, and 14 minus 3 gives us an 11. And we're done. You guys love this lesson, right? I do too. It's a good one. All right, let's try 2 more of these before we get a few word problems. Again, in the half box goes a negative 5. Watch out for missing terms. Okay, so I have 1x to the fourth. I got 5x cubed, negative 19x squared, negative 23x, but I have 0 constants. You need the 0 to hold that placeholder for the constants. I don't have any x to the 0 powers. Okay, you don't need the plus. I'm not sure what I was thinking there. Let's erase that plus. Okay, now let's go ahead and find our remainder. 1 drops straight down, times negative 5. 5 minus 5 is 0, times anything is 0. Negative 19 times negative 5. Oh, we're going to need a calculator. What is that, 95? 95 minus 23 is 72. 72 times negative 5 is negative 360. Plus 0 is negative 360. That is our remainder, which means that is the answer. All right. Last example before the word problems. We've got 7 going into our half box. Again, please do not change the sign. Okay. Now watch out for missing terms. You got 8x to the third, negative 5x squared. You have 0 x's though, and then negative 1. And let's try blue. Okay, so this 8 is going to drop straight down. 8 times 7 is 56. 56 minus 5 is 51. Times 7 is 357. Plus 0 is 357. Oh dear, I don't even have a calculator. Let's hurry and do this so you don't have to wait too long. 357 times 7. I just divided by 7 times 7 is 2,499. When I subtract 1, I get 2,498. And there is your nice, lovely remainder / answer. All right, they just want a few word problems to make sure you understand all of what you're doing here. So let's do these. They're easier than the others, I believe. But you've got a number of tickets sold during the Oakdale High School football season is modeled by this equation. So there's your polynomial. X, they're telling you, is the number of games that they're played. So we're trying to find the remainder theorem to find the number of tickets sold during the 7th game. So what they're asking us to do is really f of 7. They're trying to get us to evaluate the tickets sold for our 7th game. So we can do this using our synthetic division. That 7 is going to go in our half box, and we can just use our coefficients up here. So I have 1x to the third, negative 14x squared, 72x, and a 68. Okay, 1 is going to drop straight down. 1 times 7 is 7, goes to negative 7, negative 49. What is that? 22, 23. Oh dear. Again, so I've got 23 times 7 is 161. Whoops, 161. Then when I add that, I've got 229. Okay, so they sold 229 tickets. Again, we're only looking for the remainder. 229 tickets were sold during that 7th game of the high school football. All right, let's try this last one. This is a fun one. It's also a trick question. They give you the distance in feet that a person travels on a snowboard. So here is the distance. So if we know how long they've been snowboarding, if we know the time, t is the time, so we can just plug in a time and it'll tell us how far we've gone. So we want to use the remainder theorem to find the distance that we traveled after 1 minute. Here's the trick. We're not trying to plug in 1 for time. That's not what we want to do. 1 minute is a little bit misleading because their time is being measured in seconds. So how many seconds do we want to measure this at? Yes, we want to measure this at 60 seconds. Okay, so we're looking really for the distance that we've gone after 60 seconds. So that's what's going to go in our half box is 60 right there. Okay, let's just go ahead and put down our coefficients. We've got a 0.6, we've got a 10, and don't forget your missing term. We have 0, t to the 0 power. All right, so that 0.6 drops straight down, and grab a calculator. 0.6 times 60 is 36. Oops, 36 plus 10 is 46. 46 times 60 is 2,760, which means we have gone 2,760 feet. You're saying, how in the world is that helpful? Well, remember 5 tomatoes, 5,280 feet are in a mile. So we've got about a half a mile. That's pretty good in 60 seconds or 1 minute. All right, next video will be the factor theorem.